Same as like, so we have the RFC, types of RFCs are available, types of RFCs. Those are the connection types. These are the types of RFCs. So types of RFCs. So here we have 4 types of RFCs we have. So for 4 types of RFCs, like how the way of transferring the data, not the connection types. So just RFC types. These are the RFC types. Earlier we discussed about the connection types, right? So the way we are the way the system is sending the data, how many ways, how many types system can send the data to our remote system. There is a synchronous. One is the synchronous mode. Synchronous mode. Okay, synchronous mode. Synchronous. The second one is the asynchronous mode. So asynchronous mode. So synchronous, asynchronous mode, then QRFC and transactional RFCs. So transactional RFC, and we have queued. So here the queues will come. So queued RFC, queued RFC. Okay, these are the 4 types of RFCs we have. So what is mean by synchronous RFC? Okay, let's discuss about the synchronous RFC here. Okay, so synchronous RFC. So synchronous RFC means, so it requires both the systems should be available at the same time. Suppose this is your source system, so this is your target system. So you have created the connection. You have created the connection in SM59. So suppose for example, this is the your ECC system. So this is your BW system. So here for the synchronous RFC, both the systems should be, both the systems and both the clients, basically server should be, both the servers should be available to send the to transfer the data. So communication between, so to transfer the data, which means if you transfer the data from here to here, then this BW system, either any system, your second system will send the acknowledgement back to, your acknowledgement back to source, saying that I received your transaction, something like that. It will send the acknowledgement back to your ECC system. So here both should be available, and ECC will send the data to BW system. BW send the acknowledgement back to your ECC system. So in this way, the data is consistent. Data is consistent, which means so both should be available. So data should be, once it is received only, ECC will send the another data. Once it is received only, ECC will send the another data. That is called the synchronous type. The type is called the synchronous RFC. So which means both systems should be available. Then the target should send them, the target should send the acknowledgement to source system to deliver the message. So okay, the message has been, suppose best example, maybe nowadays or previous, so previous phones we have option. One, when you send the text message to your friend, you will get the acknowledge delivered, your message has been delivered, something like that. You will get the message. Not sure nowadays in the smartphone it is available or not. I don't see that option. So you remember, so in the phone, previous phones, not the smartphones, you have the option delivery something. If you enable it, you send the text message to him, so immediately you will get the acknowledgement, right, saying that so your message has been delivered to your friend, something like that. You will get the message. Do you agree or not? You see that messages, right?
Yes.
Right.
The delivered is, yeah.
Yes, delivered, something like that. We will get it out. So is it available nowadays in the smartphones? We don't think, right?
No.
No,
Yes,
no,
yes.
I don't think that future. Yeah, it's same kind of, same example. You can take it. So when the ECC send the data message to BW, then BW will send the back to you like that. I have acknowledged your message, I received it, something like that. Then only it will send it. Only the disadvantages here, both systems should be available. If the target is not available, then still the data is available in the ECC only. So that is the main thing here. So this is mainly used between the, so your SAP communication between the your app server to GUI. So this is the communication between the app server to GUI. This is the synchronous mode. Okay, this is the normal RFC which we are doing, right? In SM59, when you create the above to above connection, you send the data to your target system. If the connection fails, your data stuck in your source system only, right? So that is the one. So once the data transferring, one data is receiving, keep on data is receiving, so then RFC connection is fine, then data will transfer to target system. That is the synchronous mode. Synchronously data will send to the your target system. So what about the asynchronous mode? Here both is opposite. Both is opposite to,
వద్దు అన్న ఇట్టి అన్న నువ్వు ఈయన తీసుకోపో సార్ వీడు ఏదో చేసినాడు.
sorry guys. Yeah. So asynchronous means so it's opposite to the both. Here you are sending the data to your target system. Here your target system will not send the any acknowledgement back to ECC. Whether the target is received or not, don't bother about the primary. Primary means your ECC system, don't bother. So we'll keep on sending the data to here, keep on sending the data to here. Maybe whether the data is received or not, so don't bother. It's kind of postcard. Postcard means you will send the post to one target person, but you are not sure whether that person is received or not. You keep on sending the post, but the target person whether received or not, you are not sure. The target person also not sure whether I received the card. This is means acknowledgement is not required. So it does not required. Both the systems should be available at the same time execution. So both the systems are not required. Okay. So maybe mainly source system will wait. Source system does not wait for the target system should be available to send the data. Source system, your ECC keep on sending the data. With the target down also, it's keep on sending the data. That does not bother. But in the synchronous mode, it will bother about the, oh, my BW system not receiving, not sending the acknowledgement. So not received. So that I won't send the next packet, next message to my BW system. So this is this one. So here it will not send the acknowledgement. Asynchronous means it will not send the any acknowledgement back to your primary. It does not bother about a secondary down also. It does not bother. So that is called the asynchronous mode. So rare cases we will use this one. Normally they won't use it in the parallel processing. So communication between two systems, they will use it. Rare cases. Why? Because here data, we are not sure whether the data received or not. If the data is not received, your ECCs keep on sending the data, right? So there is no usage. Keep on sending the data in case if ECC is not, sorry, BW is not receiving the data. That is called the asynchronous mode. That is called the synchronous mode and asynchronous mode. So the transactional RFC. So transactional RFC is like, it kind of asynchronous RFC only. Just it's similar to asynchronous RFC, but it will assign the one transactional ID. It will assign the one transactional ID to your data. It will assign the one transactional ID to your data. Then your transactional ID to your data. Then scheduler. There is a one scheduler which will pick up by. So scheduler will pick up. It will send the data to your target system. That is the same case here. When sending the data to ECC to BW system, asynchronous RFC, you ignore it, but because it will not send any data. But the transactional RFC means the transactional RFC. The transactional RFC means it's like SM58. We can see the transactional RFC. There is a number of transactional RFC will fail in the transactional RFC. even though your target is not available. So each transaction, ECC will assign the one transaction ID. Each system, maybe I can show in our server. Maybe I will show in our server. 1 minute. Server is down currently. I am not sure what is the person is doing here. Just he told that just give me a few minutes. He will fix the issue, Linux issue. Even it's not starting up. Give me a minute. Let me. Okay. So not a problem. Then I will do the restore. I will do the snapshot restore so that we will be server will be free. So I need to stop the Linux VM. In a few minutes it will be restored. Then we are good. Okay. So while it is getting restored, so let's discuss about the some theoretically we will discuss. Okay. So transactional RFC. Each RFC, each transaction, when the transaction is when data, transaction means data, when data is sending to your BW system, it will assign the one ID, one transactional ID. Then each ID, it will go to the BW system, it will store into the BW system. In case BW not available, the data will stuck here only. When the again system is available, it will send the data to here. But if the transaction ID already received to by BW, then same transaction will stuck here. Same transaction will stuck here, and it will say that the data already exists in the your respective target system. Your respective target system. So that is what your ECC2. The transactional RFC is same as like what asynchronous RFC only, but each transaction, each data, it will assign the one transaction ID will be assigned. So the transactional ID, so it will be help to track the data whether secondary received the transaction or not. So it will down also, it will create the one ID here. Then as soon as your BW available, then it will keep the sending the data to your BW system. In case in middle BW already received the data, then it will say that the data already exists in the source target system. So in this way, even secondary down also, we have the data in the ECC, it will keep on sending to so BW system, right? It will assign the transactional RFC. So transactional RFC is an asynchronous communication methods. Okay, if the data is sent multiple times due to some network issue, some other thing, then remote system need to be available at the same time. So then immediately it will say that the data already available in the target system means so that it won't send to data to the here. So that is the ID. So transactional RFC is the unique ID. It will assign it in the system. System itself, it will assign the transactional RFC so that easily we can track it. So where can we see this transactional RFCs means in SM58, we can see that this transactional RFCs and everything we can see in the system, SM58. So let's see here. So still it is restoring. So 1 minute this much. It should not take. May take like 1 minute 57 seconds to restore. Okay, so keep it restoring. So next we'll discuss about the queue. Any questions on the transactional RFC theoretically? Just nothing. Same data will transfer to here. Even BW not available, remote system is not available. It will keep it here and then send it here. While keeping it here, it will assign the one ID, one reference ID. It will assign it. Suppose when you are applying to the one post or one position, after that there is a reference number will be generated. Through that reference number, everything will be tracked, right? So here also, when you are applying to the one position, for your reference, for your user reference, one reference number will be generated. If you apply the same person will apply the different transaction, it won't go. Why? Because system will tell like, okay, data already exists in the system, don't process something like that, it will tell, right? So this is the thing will happen regarding the transactional RFC. So queued RFC means it's like extension of the TRFC, transactional RFC. So queued RFC means queues wise in the system we have the queues wise properly, orderly, serially it will send the data. Otherwise it will send the data to our target system, that is called the queued RFC, QRFC. So the transactions will process in the form of LUW. Maybe if I show in the system you can understand better way, right? So instead of that one, so if I show in the system you can understand easily. So let's wait for this one, how much time it will take. Oh, got it. Restored. System is restored back. The thing is, what happens yesterday? This mount point got missed. Okay? Now system is restored. System is started. Just want to verify the. Okay, we have enough space. So let me do the. You can also see what I am doing here. Maybe I will pause it here, the recording for some time. We are discussing about RFC types, QRFC, transactional RFC, queued RFC. In SM59, SM58, we can see the RFC, transactional RFCs. So normally this is a system. I think we don't see any transactions, I guess here. Yes, we have the transactions, failed transactions. Here real time also we will get the similar type of failed transactions. You see each transaction, each data, so you have the transaction ID, TID, transaction ID generated, transaction ID generated. So this transaction ID which is stuck in the system, which is stuck in the system. So why? Because we can see the reason, name and password is incorrect, password is no longer possible, too many attempts. At what type of data? 13th data, 14th data, we have all the data got stuck. So this is the destination which is using to send the data to target system. This is the target system which is using to send the data. Through this RFC, our SAP ECP system sending the data through this RFC. Who is sending? Who is the caller here? Basis. Basis done these transactions, and DDIC user done these transactions, and what other users? So all of the DDIC, and most of the people we are using the DDIC, right? You can see each transaction we are sending the data to respective systems. So how can you see such system? Means you can see the target system here. So there is a target system transaction here. So through this destination, through this RFC destination, where is so through this RFC destination, so we are sending the data to target system in the form of transactional RFC, which is there in the system. So if the target system down also, so the data will be available in the source system in the form of transactional ID. So if the source system is down, once the source system is up, then it will send the data to your target system. It will send the data to your target system. Send the data to your target system. So suppose due to some network issue, the data already exists here, means it won't send the data to here. Why? Because each transaction there is a ID, transactional ID, it is recorded. So system knows, system will record these changes. Okay, this data I am sending to this person. So if again the person says, so I have not received the data, means when you're trying to send, system does not allow you to send the data because of the data already available. We have the track, right? We have the record, we have the ID is there. So it will say the data already exists in the target system, something like that. We may get the issues. Okay, this is the transactional RFCs. Okay, got it? Any questions from anyone? So not only this system, we can send the data to multiple systems, multiple BW systems, BW, ECC, CRM, EI. So from here to here, we may get lot of data. We may send the data to here. Then this systems also will send the data to us as well. This systems also will send the data to our system as well. So those things we can monitor it. Those things we can monitor in the form of queues. Queues means SMQ1, SMQ2. These are the transactions. SM58 is for the transactional RFCs. So SMQ1 and SMQ2 is for the inbound and outbound RFCs. So inbound, outbound RFCs means, suppose if you go to the SMQ1 transactions, outbound, which are going out, out means, yeah. So in the form of queues, it will send the data. So you guys clear with the SM58, right? SM58 transactional RFCs, you guys are clear, right? There is no doubt in that one. So, and what about the queued RFC? Queues, in the form of queues, system will send the data to in the form of queues. Queue means order. Order wise, it will send the data to your respective target systems. So in SMQ1, outbound queues, which is sending out of the system. So which means if any data stuck here, the data will be available here. So inbound queues, SMQ2 is the inbound queues, which is coming inside of the system. Sir, where can I see the queues and everything? So here, if you go to the SMQR, queue in queues, inbound queues, here we can define the queues actually. Here we can define the queues. Suppose CRM queues, CRM star related queues, it will come through this destination. So, and also you have the other queues. it will come to this destination. Something like that you are maintaining here. Something like that we are giving the details here. So that is the queue in. Queues we are maintaining here. So what happens when the data comes inside when the data comes in the queue in scheduler, it will send the data to automatically. It will send the, no one will send, only the scheduler will send the data. So SMQS, outbound queue scheduler, outbound queues means, so what is the destination you are using here? Suppose outbound, out, which server you are sending the data. So that destinations we have to maintain here. Suppose you are sending the data to, suppose like, so NWD system, all right, NWD destination you can create it here. Suppose you are sending the data to some BW system. What is that BW system here? So some Google, then you can take the Google here. So like that we can define the queues here, define the queue out, which is going from ECP to other systems. Those destinations we can maintain here. Those destinations we can maintain here, so that it will send the data to respective system. Queue out, queue in means SMQR. SMQR means queue in, which is coming inside of the system, which is coming inside of the system, which is coming inside of the system. So here we need to define the queues. We means our functional team will define the queues here. Our functional team will define the queues here. So that's why we have to define the queues here, so that through this queue the data will come inside of the system. Maybe if I take the diagram diagrammatically, so this is okay. So let me take it here. This is your ECC system, ECP system, right? This is your ECP system, ECP. So you have one BW system here, you have one ECC, one CRM system here, we have one more system here. Like that, we have the system. ECC is the main system in the organization. So here you have SMQR. So suppose you want to send the data to, so BW system, then you can send the data RFC destinations, you can create it. So this is the BW system. You can send the data to BW system, maybe CRM system, you can send it. You can send the data. So then how you can send it? Through destination, through RFC destination, you can send the data. Destination, through destination, you can send the data, right? Destination, you can send the data. But where we have to configure which data should go to this destination, which data should go this destination, how the system knows, which means here in SMQR, so QR is for the in, SMQS, here you need to define the destinations. So what is the destination? Here you have to use it for the CRM. So how many connections should create it? So like that you have to create the connections here. Like that you need to create the connections, so that through this connection, once you create the connection, through this connection, so data will send it to the queue out, right? Data will send it to the respective BW system. Sir, how can I know, sir, this is sending to this, the data is going to the not? How can I know? Through RFC destination, it will go. It will not say to hi to her or hello to us, right? It will send system internally, it will process it. But how can I say, sir, how can I see whether data is stuck or not, right? We can see here in the queue out, right? SM Q1, here we can see whether the data, any data stuck or not. Here we can see in the outbound queue. In SMQ1, here we can see SMQ1, here we can see in the, we can monitor the queues, all the queues we can monitor it. So outbound queues we can monitor it, whether the data is going to the these destinations or not. We can see configuration, we know SMQR, SMQS we can see, but where can I monitor my data stuck or not means SMQ1, SMQ2 we can see. So Q1 is for the, which is coming inside of the system, which is coming inside of the system, which is coming inside of the system. Here we can make my data stuck in the, so Q2 or not, here we can see Q2, Q2, here we can see here SMQ2, SMQ2. So inbound queue. So system internally your database having problem from outside system to data is not coming to the your inside of the ECP system. Those are called the inbound queues. Here we can monitor. So SMQ2 we can monitor data stuck or not. So here there is no data stuck here. That's the reason it's green 00. So if data stuck, the entries will be displayed here. The entries will be displayed here. The configuration we can make it in the SMQR and SMQS, so that when the data generates in the ECC system, automatically the queues will process to respective system, right? When the transaction is happened here, suppose I am the one user, I logged into the here, I done the one transaction something here, the ECP system, I done the transaction. Immediately the transaction you done it, the transaction should go to the BO systems and BW systems for analytics purpose. Immediately these queues will process to so your BW systems. Same transaction is required for the CRM. It will go to the CRM system as well. Same transaction is required for the your BO also, BO bots reporting purpose. Then it will send it to the bots as well, right? So this is the queues we can monitor in the system. That's the queued RFC. Queues wise data will send to the your respective systems. Queues wise data will send to the respective systems. It's going out of the your ECC means outbound. It's coming in means inbound queue. SMQ1, SMQ2, SMQR, SMQS, SM58. So these are the transactions. SMQ2, SM58, then SMQR, SMQS. So these are the transactions for the transactions and queues related information. Okay, got it? Any questions from anyone? Any confusion? Why? Because server means not only within the system, we have to send the data to other systems. Other systems will send the data back to our system. So the communication should happen both the either side. So in this case, RFC destination is very important. While sending the RFC connection to other systems, here we need to take care of the how it is sending. Destination you created, then how the system knows through this destination only I have to send the data. Then you need to register the queues here. So that's the main aim, bottom line of this queues concept, right? You got it? So let me check the performance of this one. What is the performance of this system? So it's very less performance, it's very fast compared to yesterday. Yesterday it's very slow, but today it's very fast. Right, we have the data ST03. Okay, everything is there. Yeah. So this is the queues. So what about our NWD? NWD also we can see the where can we check the system response time? SMLG. We go to the SMLG. We check the load distribution. Here see initial starting. So 19,000 milliseconds. Again refresh. Come to the 2000 milliseconds. So here already 2 users are there in the system, right? So just you can keep on monitoring it. It will decrease it here. Okay. So this is the queues related. So any questions from anyone? Systems are green, so no one disturb you from now onwards. So they won't disturb you. So you can work it out, no problem. Systems are green now. So this is our server. Okay. So any questions before I go ahead and check my things here?